Today's lesson is day 2 for solving equations. Yesterday we began solving equations with reviewing how to work and solve linear equations, how to work with quadratics and solve them, and also how to solve irrational equations. Today we're going to look at higher order polynomials, radicals, and absolute value. Well, beginning with the higher degree polynomials, we want to factor these whenever we can. If you can't factor it, sometimes you can also do the root method, depending on how it starts off. On this first example for A, notice that the equation is not in standard form, so let's set it equal to 0. And then notice that I could factor that into x squared minus 1 and x squared minus 3. The x squared minus 1, you could solve that factor, or you could also realize that that's x minus 1, x plus 1. That's one of our special factoring patterns. And then by the zero product property, we can set each one of those equal to 0. So notice that we'll get x is equal to positive 1 or negative 1. And then for my third factor here, I've got x squared minus 3 is equal to 0. And so we'd have x squared is equal to 3, square root both sides, and then we get x is equal to plus or minus square roots of 3. So I've got 4 solutions here total. And again, we want to make sure that we use simplified radical form and no decimals. Looking at example 5, working with radicals. All right, there's two situations that you're going to encounter with the radicals. If you have an equation with exactly one radical, then what you do is you isolate the radical, square both sides, and then these require that you check. So notice that to isolate the radical here on this first example, I have root 3x minus 2 is equal to x minus 2. And then I'm going to square both sides. So my left-handed side, the square and the square root are going to cancel, and I have 3x minus 2. And then the right-hand side, notice, is one of my special patterns. And recall that the pattern, when we have a binomial, the square of a binomial is a squared plus or minus 2ab plus b squared. And if you can't remember that pattern, you can always use FOIL if you want to write it out and multiply it out that way too. That's fine. So the right-handed side, we get x squared, minus 4x plus 4. Now, setting the equation equal to 0, notice that I would get x squared minus 7x plus 6 is equal to 0. And then by factoring, that one's pretty easy to factor. I've got x minus 6, x minus 1, and then by the zero product property, I have x is equal to 6 or x is equal to 1. All right, these require that you check. So let x equal 6. So then notice that we would get the square root. So I'm checking, I'll go back to my original problem here. So I've got the square roots of 18 minus 2 minus 6. Is that going to equal negative 2? So 18 minus 6, of course, is 16. That's going to simplify to 4. And then 4 take away 6 is that negative 2. And yes, so 6 does check. All right, checking the next value here, I've got 1. All right, so this time I've got the square roots of 3 minus 2 minus 1. Is that going to equal negative 2? And the square roots of 1 is just 1, and then 1 take away itself is 0. And so 1 is a fail. So here there's only the one solution, and that's at x equals 6. Now, what happens when you have two radicals? If you have two radicals, the procedure is similar, but you have to do it twice. First, pick either radical and isolate it, square both sides, and simplify. Then isolate the radical, the second radical, and then square both sides again. Lastly, always check for extraneous. It doesn't matter which root you want to isolate. I'm going to isolate the first one, the square roots of 3x plus 4. And then notice that my right-handed side would be 1 plus the square roots of x plus 5. Right now, square both sides. Left-handed side is 3x plus 4. All right, now the right-handed side, you've got to be careful because this is still your special pattern. So it's a squared plus 2a times b plus b squared. And then notice that you've got some like terms. So the 1 and the 5, of course, are going to sum to 6. So then combining those with the left-handed side, notice that we would get 2x minus 2 is equal to 2 on the square roots of x plus 5. Now I'm going to divide out my 2, and so I would get x minus 1 is equal to the square roots of x plus 5. Now I'm ready to go ahead and square again. So I've isolated the second radical, and now I'm going to do the same procedure one last time. Left-handed side, special pattern again. So I've got x squared minus 2x plus 1 is equal to x plus 5. And then setting the equation equal to 0, notice that we would get x squared minus 3x minus 4 is equal to 0. Every quadratic we try to solve by factoring, and this one's going to factor nicely for us. And so then my solutions look like it's 4 and -1. Again, we can't assume that these are going to work, so we've got to check each one. So we'll start off with 4. So then I get the square roots of 12 plus 4 minus the square roots of 9. Is that going to equal 1? So I get 4 minus 3, does that equal 1? And that's a check. So 4 works. And then for -1, so I get 1. So I have -3 plus 4, so that gives me the 1. And then minus, and then I've got the -1 plus 5. And then is that going to equal 1? Okay, so notice here I get 1, and then minus 2. Is that going to equal +1? And that's a fail. So that means then that my only solution here is +4. All right, last kind of equation that we're going to look at today is the absolute value type. And remember, when we're dealing with absolute values, what we have to do is we have to isolate the absolute value, and then you rewrite as two equations, one positive and one negative, and then you check for the extraneous solutions. So when you rewrite the absolute value as two equations, that's when you drop the bars. So the absolute value bars get dropped when you do the two cases. All right, looking at example 6a here. So the absolute value is already isolated, and so we're going to just do the two cases. So I'm going to have the positive case and then the negative case. All right, so the positive case, I'm just going to keep everything exactly as it is. 3x plus 7 equals 4, and again, no bars. For the negative case, the left-handed side I'm going to keep the same, and then the right-handed side becomes negative 4. So the positive and negative case I'm making on the right-handed side. Right, and then solving each one. So notice I get 3x is equal to negative 3, and then x is equal to negative 1, and then 3x is equal to negative 11, and x is equal to negative 11/3. All right, and then again, we've got to check. So for negative 1, notice that I get the absolute value of negative 3 plus 7. Is that going to equal 4? And of course, that's a check. And then for the second case here, notice that I will get negative 11 plus 7. And is negative 4 the absolute value of negative 4 equal to 4? The answer is yes, so that's also a check. So this one has two solutions. All right, looking at example B here. So I've got the absolute value of quantity x squared minus 6 equals x. All right, so I'm going to do the two cases. So here's the positive case. And then over here is going to be the negative case. All right, so the positive case, I'm just going to drop the bars and keep everything exactly as it is. And then for the negative case, I'm going to take the right-handed side and make that negative. All right, so again, the positive case, everything stays exactly the same. The negative case, you make one side of the equation negative. Now for my solving, notice that I've got quadratics for both. So I'm going to have x squared minus x minus 6 is equal to 0. And then that's going to give me x minus 3, x plus 2. And so then my solutions here are going to be 3 or negative 2. And then for my second equation, notice that I'm going to get x squared plus x minus 6. So this is going to give me x plus 3 and x minus 2. And so then I've got negative 3 or positive 2. And then again, you have to check each one. Okay, so my first one, I'm going to check x is equal to 3. So notice that I would get the absolute value of 9 minus 6. Does that equal 3? And of course, that's a yes. So that one checks. For negative 2, notice that I would get 4 minus 6. Is that going to equal negative 2? And that's going to be a fail. So negative 2 is not a solution, but x equals 3 is a solution. Moving over to my second set. So checking negative 3. So I've got the absolute value of 9 minus 6. Is that going to equal negative 3? And that's going to be a fail. So negative 3 does not work. And then for 2, notice I would have 4 minus 6. Does that equal 2? And yes, that is a solution. So that one checks. All right, so we've got two solutions here, x equals 3 or x equals positive 2. All right, hopefully you're kind of remembering what these equations feel like for solving on them. And today's assignment is the solving equations worksheet, and it's day 2 in your packet.